Today we are going to discuss about matrix method of finding DFT and IDFT. Consider n point DFT of x of k of the sequence x of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi nk by n, where k varies between 0 to n minus 1. We know that omega n of nk, fiddle factor, we can write as e power minus j 2 pi nk by n. So analysis equation or above equation we can write x of k is equal to summation n is equal to 0 to n minus 1 x of n into omega n of nk, where k varies between 0 to n minus 1. Let us expand the above summation on the RHS of above equation. We get x of k after expanding is equal to first value x of 0 into omega n of 0 plus x of 1 into omega n of k plus x of 2 into omega n of 2k plus so on x of n minus 1 into omega n of n minus 1 into k. So from this above equation we can write n number of equations. So that means we can vary the value of k from 0 to n minus 1. So x of 0 is equal to x of 0 into omega n of 0. Change the value of k to 0. X of 1 into omega n of 0 plus x of 2 into omega n of 0 plus so on up to x of n minus 1 into omega n of 0. Similarly, we can write x of 1 is equal to x of 0 into omega n of 0 plus x of 1 into, now change the value of k to 1, plus x of 2 into omega n of 2 plus so on up to x of n minus 1 into omega n of n minus 1. So we can write n number of equations. So last value x of n minus 1 is equal to x of 0 into omega n of 0 plus x of 1 into omega n of n minus 1 plus x of 2 into omega n of 2 into n minus 1 plus so on x of n minus 1 into omega n of n minus 1 into n minus 1. So in matrix form, we can write the previous equation as, in matrix form, left hand side it is x of 0, x of 1, x of 2, so on x of n minus 1 equal to is omega n of 0, omega n of 0, omega n of 0, last value is also omega n of 0, omega n of 0, omega n of 0. The first column will be omega n of 0 itself. Second column will be omega n of 0, omega n of 1, omega n of 2, omega n of n minus 1. And next is omega n of 0, omega n of 2, omega n of 4. So up to omega n of 2 into n minus 1. So we can write n number of equations. We get it is omega n of n minus 1, omega n of 2 into n minus 1. Up to last value is omega n of n minus 1 into n minus 1 into x of 0, x of 1, x of 2, so on up to x of n minus 1. Then the matrix equation can be symbolically represented as x is equal to omega n into x, where capital X is equal to DFT matrix of order n cross 1, omega n is equal to coefficient matrix of order n cross n, x is equal to time domain sequence matrix of order n cross 1. Let us write the coefficient matrix for n is equal to 4. That is, generally we can write omega 4 is equal to omega 4 of 0, 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 omega 4 of 1, omega 4 of 2, omega 4 of 3, omega 4 of 0, omega 4 of 2, omega 4 of 4, omega 4 of 6, omega 4 of 0, omega 4 of 3, omega 4 of 6, omega 4 of 9. This is the coefficient matrix, where omega 4 of 0 is how much? 1. Omega 4 of 1, that means e power minus j 2 pi k by n. Capital N value is 4, small n value is 1, which is equal to what? K value is 1. E power minus j pi by 2, which is equal to cos pi by 2 minus j sin pi by 2, which is equal to minus j. Similarly, omega 4 of 2 is equal to e power minus j 2 pi k by n, which is equal to e power minus j 2 pi into 2 divided by 4, which is equal to e power minus j pi cos pi minus j sin pi, which is equal to minus 1. Next we have omega 4 of 3 e power minus j 2 pi into 3 divided by 4, which is equal to e power minus j 3 pi by 2. That means cos 3 pi by 2 minus j sin 3 pi by 2, which is equal to j. Then omega 4 of 4, we can write it as omega 4 of 2 into omega 4 of 2. Omega 4 of 2, we already found it is minus 1 into minus 1, answer will be 1. Then omega 4 of 6 is omega 4 of 4 into omega 4 of 2, which is equal to omega 4 of 4 is 1, omega 4 of 2 is minus 1, which is equal to minus 1. Similarly, omega 4 of 9 is equal to omega 4 of 4 into omega 4 of 4 into omega 4 of 1, which is equal to 1 into minus j, which is equal to minus j. Therefore, we can write the coefficient matrix when n is equal to 4 is, it is 1 1 1 1 1 1 1 minus j plus j, here it is plus j minus j, and remaining values are minus ones, and here it is 1. So this is the matrix we are going to use while solving the problems. Let us solve some of the problems on this topic. First problem, find the 4-point DFT of the following sequences. Using matrix method. First one, x of n is equal to 3, 2, 0, minus 1. So left hand side we have to write, it is 4 point, x of 0, x of 1, x of 2 and x of 3, and we have to write standard coefficient matrix for this 1 1 1 1 1 1 1 minus j plus j minus j plus j, here it is plus j minus j minus 1 minus 1 minus 1 minus 1, here it is 1. That should be multiplied with given matrix 3, 2, 0 and minus 1, which is equal to, first one is 3 plus 2 plus 0 minus 1, second one is 3 minus 2j minus 0 minus j, 3 minus 2 plus 0 plus 1, 3 plus 2j plus 0 plus j, which is equal to, after simplification we get 4, 3 minus 3j, 2 and 3 plus 3j, or we can write x of k is equal to 4, 3 minus 3j, 2, 3 plus 3j. So we can note one point here. In the previous problem, the first DFT sample, whatever the answer we got, first one is the algebraic sum of the time domain samples. That means the given samples. What are the samples given? We have to add that and we will get the answer. For example, in the previous problem, time domain samples are 3, 2, 0 and minus 1. If I add all these values or algebraic sum, we get 3 plus 2 plus 0 minus 1, which is equal to 4. That means which is the first DFT sample. Similarly, the fourth DFT sample is the conjugate of the second DFT sample. So we should remember this and we can cross verify the answer once we solve the problem. Next problem, x of n is equal to 0, 1, 2, 3. You have to find using matrix method. X of 0, x of 1, x of 2, and x of 3, which is equal to standard matrix we have to write multiplied with 0, 1, 2, 3. So already we know first answer will be sum of the given samples, that means it is 6, and we have to solve remaining. Second one you will get it as -2 plus 2j, third one is 2, then fourth one is conjugate of second one means -2 minus 2j. So we can write x of k is equal to 6 minus 2 plus 2j minus 2 minus 2 minus 2j. Next problem, find the DFT of the given sequence x of n is equal to length of n plus 3 using matrix method. We know that this is non-causal sequence, so we have to convert it into causal sequence using periodic signal. So it is given, the signal is present at minus 3, this is 0, this is minus 1, minus 2, and minus 3. It is given, signal is present, this is non-causal, this is x of n given, x of n is equal to 1, 0, 0, 0, it is given like this. This is x of n. Now we have to convert it into causal sequence. That means the signal is periodic with n minus n naught. That means the signal is present, so causal sequence. After 4 points, the signal is present at -3, then -2, -1, and 0. Once again, the signal is present at 1. Then once again present at 4. So I can write the answer as x of n is equal to 0, 1, 0, 0. Now we can solve this using matrix method. X of 0, x of 1, x of 2, x of 3 is equal to 1, 1, 1, 1, 1, 1, 1, minus j plus j, j minus j, minus 1, minus 1, minus 1, minus 1, and 1. That should be multiplied with 0, 1, 0, 0. Answer will be 1 minus j minus 1 and plus j. So conjugate of second one. We can write x of k is equal to 1 comma minus j minus 1 and plus j. Next problem, x of n is equal to n into e of n minus e of n minus 4. That means the signal is present from 0 to 3. We can write it as is present n when n varies between 0 to 3 and 0 elsewhere. So we can write x of n as 0, 1, 2, 3, or x of 0, x of 1, x of 2, x of 3 is equal to 1 1 1 1 1 1 1 minus j plus j j minus j minus 1 minus 1 minus 1 minus 1 1, it should be multiplied with 0 1 2 3. So answer will be 6 minus 2 plus 2j minus 2 minus 2 minus j2. X of k is equal to 6 minus 2 plus 2j minus 2 minus 2 minus j2. Next we are going to discuss about matrix method of finding IDFT. Now consider IDFT equation x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k into e power j 2 pi nk by n, when small n varies from 0 to n minus 1. We know that omega n of nk is equal to e power minus j 2 pi nk by n, and omega n of star nk is equal to e power j 2 pi nk by n. So we can write x of n as 1 by n summation k is equal to 0 to n minus 1 x of k into omega n of star nk, where n varies between 0 to n minus 1. So we can write n number of equations using previous equation and represent these equations in matrix form as given below. That is, small x is equal to 1 by n into omega n of star into x, where small x is equal to sequence matrix of order n cross 1 omega n star is equal to conjugated coefficient matrix of omega n of order n cross n. Capital X is the DFT matrix of order n cross 1, and n inverse or 1 by n is the scalar multiplication. Then the coefficient of omega n of star matrix can be obtained by conjugating every element of matrix omega n. Let us write the matrix relation for 4-point IDFT. That is, omega n star is equal to 1 1 1 1 1 1 1 So it is conjugate of previous matrix minus j is plus j is minus 1 minus 1 minus 1 minus 1 and 1. Let us solve some of the problems on this. First one, find the IDFT using matrix method. Is given x of k is equal to 2 comma 1 plus j 0 comma 1 minus j. So left hand side it should be small x of 0, x of 1, x of 2, x of 3. Scalar multiplication is there. So it is 1 by 4 into 1 1 1 1 1 1 1 j minus j minus j j. These are minus 1 and this is 1. That should be multiplied by 2 1 plus j 0 1 minus j is 1 by 4 into 4 comma 0 0 4 or x of n is equal to 1 comma 0 comma 0 comma 1. Next problem, find the IDFT of the given sequence using matrix method. X of k is equal to 4 comma minus j2 0 comma j2. So it is x of 0, x of 1, x of 2, x of 3 is equal to 1 by 4 into 1 1 1 1 1 1 1 j minus j minus j j minus 1 minus 1 minus 1 minus 1. This is 1 into 4 minus j2 0 and j2, which is equal to 1 2 1 and 0. Then x of n is equal to 1 comma 2 comma 1 comma 0. This is the required answer.